Hi there and welcome to Hegarty Maths. It's Mr. Arnold here and this is the first video on integration. We're going to look at simple indefinite integrals and it is geared towards A-level core maths but is applicable to most other maths modules. Okay, so integration. Before I continue, what I would suggest is you ensure that you look at the videos on differentiation first because it's going to make understanding this concept far easier. So integration is simply the reverse of differentiation. So if we had a function y equals 4x cubed plus 3x squared plus subtract 2x, we can work out dy by dx. So the derivative of y with respect to x will give us 12x squared plus 6x subtract 2. Well, if I was to integrate this function here, 12x squared plus 6x minus 2, it should take me back to this. Plus 6x minus, not 6x, plus 3x squared minus 2x. It should take me back. If I integrate this function here, I should get back to where we started. So it's the reverse process of differentiation. Now the only thing is, we need to consider what would happen if I was to differentiate this and then integrate it. dy by dx would be 12x squared plus 6x subtract 2. So if I integrate this function, given here, I should also get 4x cubed plus 3x squared subtract 2x plus 5. Now, if you look at the original, which is this function here, when I took the derivative, I had 12x squared plus 6x minus 2. And if I have this function here, when I take the derivative, I also get 12x squared plus 6x minus 2. However, if I integrate those functions, we can see that one is different to the other. So when we integrate functions and they're indefinite integrals, I'll explain what that is in a bit more detail later, we must include the constant of integration c. So if I integrate this function here, I must remember to include a constant of integration c because we may have something tagged on the end here. So there could be any number here because if I take the derivative of any constant I get 0. So just in case, when we integrate a function we should always add the constant of integration c, and that's for indefinite integrals. Those are integrals where we're not trying to evaluate anything. So in general, this is how it works. If we have a derivative kx to the power n and I integrate it, so if I want to go backwards, what we do is we increase the power by 1 and then we multiply by 1 over this power here, and then not forgetting to add on that constant c. Now the notation can look quite complicated at first, however it'll all become a lot clearer with a few examples. And you can always check your work by differentiating what you had, or what you end up with, I beg your pardon. If you differentiate what you had after you integrate and you get back to the original, then your answer should be good. So let's see how this works. So here I want to integrate with respect to x the expression x squared. So what I can do is we can write it like this. I is going to be the integral of x squared with respect to x. So this symbol here is an elongated s Now my writing probably doesn't do it justice. It's like this. It's an elongated s, that means integrate. And then we have this dx on it at the end of the expression to highlight that we're integrating with respect to x. So I is going to be my integral of x squared with respect to x. So let's apply the formula. So that's going to be equal to, now, what does the rule tell me to do? I'm going to increase the power by 1. So let's increase this power by 1, so which will give me a 3. And then multiply by 1 over n plus 1. So multiply by 1 over that new power. So 1 over 3. Now I'm going to check. I'm going to do a check over here. If y equals 1 over 3 x cubed, then dy by dx. So let's integrate. The power comes down by in front. 3 times 1 over 3 is 1. So we get 1x, and reduce that power by 1, 1x squared, which is exactly what we started with. So we know that we're correct. Let's do another example. So here we're increasing the power by 1. So I will be the integral of x to the power of negative 4. And we're going to integrate with respect to x. That's what this dx means. We're integrating with respect to x. And let's apply the rule. So we increase the power by 1. So negative 4 plus 1 gives me negative 3. So increasing the power by 1. And then multiply by 1 over n plus 1. Well, what is n plus 1? It's negative 3. So negative 1 over 3. Now I have to be very careful because I totally forgot, and hopefully you picked up on that. I forgot in the last question to add that constant of integration c. Let's just go back and change that. I should have had a constant of integration c, and you'll see here if I integrated some, if I differentiate some constant, it becomes 0, so it would disappear. Let's try and not make that mistake again. Now let's check our answer, make sure that we're doing things correctly. We're going to do a check over here. Okay, so suppose we had the function y equals negative 1 over 3 x to the negative 3 plus some constant c, and we take the derivative dy by dx. Well, negative 3 is going to come down in front, so I'll have negative 3 times negative 1 over 3, which would give me a positive 1. I'm going to have x. I need to reduce that power by 1, which would give me a negative 4. And the derivative of a constant is 0. So dy by dx equals x to the negative 4, which is what we had to begin with. Okay, let's try example 3. So now we have 3x squared. So I'm going to integrate with respect to x. So I will be equal to the integral of 3x squared, and we're integrating this with respect to x. That's what the dx means. And now we're going to use this rule over here. So we're going to increase the power by 1. Let's just worry about that first. So increasing that power by 1, we get a 3. We have a 3 in front of the x, and I need to multiply that by 1 over n plus 1. Well, n plus 1 is 3. So it'll be 1 over 3 times 3x cubed. So 1 over 3 times 3x cubed. And don't forget that constant of integration c plus c. Well, 1 over 3 times 3 is 0. Not 0, I mean 1. 1 over 3 times 3 is 1. So we end up at 1x cubed plus c. Let's see if we're correct. So let's do a check. And it's good practice right up until you're really confident with this to do the check every time. So suppose we have the function x cubed plus some constant. So we have y equals x cubed plus some constant. Take the derivative dy by dx. So 3 comes down in front. Reduce the power by 1. We get 3x squared. And the derivative of a constant is 0. So absolutely brilliant. That's worked out perfectly for us. Okay, let's try another one. So a little bit more complicated. You might want to pause the video and try it yourself. So we're integrating with respect to x. So we have I is going to equal the integral of 6x to the negative 2 with respect to x. And that's going to equal. Now, just to make life a little bit easy at first, I'm going to deal with the power. So I'm going to end up with x, increase that power by 1, x to the negative 1. K is in front for both, so let's leave it there at first. Now you will get much quicker at this as time goes on. And 1 over x to the n plus 1, well n plus 1 is negative 1, so it's 1 over negative 1. And don't forget that constant of integration, c. Well, 1 over negative 1 is negative 1, and negative 1 times 6 is negative 6. So you get negative 6x to the negative 1 plus c. Once again, let's do a check. Make sure that we're doing things correctly. If y was equal to negative 6x to the negative 1 plus some constant c, then dy by dx would equal, the power is going to come down in front, so negative 1 times negative 6 is positive 6. Reducing that power by 1, we get x to the negative 2, and the derivative of a constant is 0. So once again, we end up back where we started, so we know that we're correct. Okay, example 5. So slightly more complicated now. We're dealing with a fraction in front of a fractional coefficient. Okay, so I is going to equal the integral of 3 over 4 x to the negative 3 with respect to x, which is going to equal. Now I'm going to actually show you something which applies to the other questions. I'll go back to them in a moment. But let's do it the way we've been doing them so far. So we're going to increase the power of x by 1. So increasing that power of x by 1, we get x to the negative 2. The coefficient of x, or k in this case, is 3 over 4. So let's leave it like 3 over 4. And we're going to multiply that by 1 over n plus 1. Well, n plus 1 is negative 2. So 1 over negative 2. Which is simply negative 1/2 times 3 over 4 x to the negative 2. And hopefully you're okay with multiplying fractions. We're going to get negative 3 over 8 x to the negative 2. Now you might see it written in books, in textbooks, sometimes like this. Negative 3 x to the negative 2 over 8. Same thing. I just find it much easier to leave the fraction in front. I find it a lot easier to deal with that way. But you might have your own preference. Okay, we're going to do a check and then I'm going to show you something else. So a check here. Suppose we had negative 3 over 8 x to the negative 2. So y equals that. Let's work out the derivative dy by dx. Oh, and let's also remember our constant c. So we're checking. dy by dx, negative 2 times negative 3 over 8 is going to give me positive 6 over 4, over 8, which would be 3 over 4. And increasing that power, or reducing that power of x by 1, so negative 3. And the derivative of a constant is 0. So that works out nicely. Now, something that is certainly a useful tool, and is that the constant 3/4, actually we don't need to worry about integrating that. So I could have done this, I equals, and I can take that constant out in front, I equals 3/4 times the integral of x to the negative 3 with respect to x dx. So let's just worry about integrating this part and then deal with the 3/4 later. So 3/4, integrate this, we're going to increase the power of x by 1, which gives me a negative 2. I need to multiply by 1 over negative 2, like so. And don't forget that constant c. So now I can multiply this in. In fact, to be more accurate here, I should include the c inside. Now multiplying 3/4 in, we get negative 3 over 8 x to the negative 2 plus, well, 3/4 of some constant. And 3/4 of some constant is just some constant, some number. So it's the same thing. And you might notice, we go back to this question here. Let's just do it slightly differently. So I could factor that 6 out, equals 6 times the integral of x to the negative 2 dx. So don't worry about the 6 yet. We're just going to worry about integrating this part here, integrating x to the negative 2. Well, I need to increase the power by 1, which gives me negative 1, and multiply by 1 over negative 1, which is negative 1. So 1 over negative 1 is like that, plus the constant c. And then if we expand this in, well, 6 times 1 over negative 1 is negative 6 x to the negative 1, and 6 times c is going to give me 6c. 6 times a constant is still just a constant. So we still end up with the same thing. So you might want to bear that in mind when you're doing some of these questions. Okay, slightly more tricky example. Here it doesn't say anything, but it's telling me what to do. It's telling me to integrate this expression with respect to x. So I is going to be equal to, well, if I integrate a constant 7, if I integrate the constant 7, that's just like 7x to the power 0. 7 times 1 is 7. So I need to increase the power of x by 1, which is going to give me 7x minus. Now, same idea again. We're integrating each term, just like we would if we were differentiating, just integrate each term. So integrating x squared, I need to increase the power of x by 1, which will give me a 3, and multiply by 1 over 3. And then not forgetting that constant. So let's check, make sure that this is done correctly. So the check, if y was equal to 7x minus 1 over 3 x cubed plus some constant, I'm hopeful that we get back to this. Well, let's do dy by dx. Derivative of 7x is 7. Derivative of this, 3 comes down in front. Multiplied by 1 over 3 is going to give me minus 1. x to the power of 2, which is actually just minus x squared. So minus x squared, and the derivative of a constant c is 0. So we do end up where we started. Okay, 2 more to go. Now I'm asked to work out the derivative or the integral of this. We're going to make life a little bit easier for ourselves, but just let's sort this out. It's actually going to be the same as the integral of, and expand this out. So x times x is x squared. When we expand it out, we're going to get negative 4x plus 4. So this is what I'm actually going to integrate with respect to x. So we just expand that expression. Make life easier for ourselves. And now integrate each term individually. So the integral, will be equal to, okay, x squared, let's integrate it. I'm going to increase the power of x by 1. I'm going to multiply by 1 over that number. Let's do the next one. Increasing the power of x by 1, so we get x squared. And multiply by 1 over that number. So I'm going to get 4 times 1 over 2, which is 4 over 2. And then integrating the 4, integrate that 4, so it's like 4x to the power of 0. So a constant 4 is just the same as 4x to the power of 0. So increase that by 1. And we get 4x, like so. And you should know that if we take the derivative of 4x, we get 4. Once again, don't forget your constant of integration c. And let's tidy it up. So 4 over 2 is the same as 2. 1 over 3, x cubed minus 2x squared plus 4x plus c. Let's do a quick check. So check, I'm going to take the derivative here. 3 times 1 over 3 is 1, so we get 1x reduced the power by 1 squared. So we're taking the derivative of this function. Taking the derivative of this. 2 times negative 2 is negative 4. Reduce that power by 1. And then the derivative of 4x is simply 4. Derivative of a constant is 0. So we end up with this. And clearly that expression is indeed the exact same as that expression there. So we're perfect. Okay, last question now. So hopefully you might think what to do here. Maybe you want to pause, give it a go. Alright, I don't like having this x on the bottom, and I don't like having this squared. So let's just deal with these issues first. I'm going to write it as the integral of x minus 4x to the negative 1, so using the laws of indices to bring this guy up, squared, which is the same as, and I'm going to draw this out a little bit, make it easy, x minus 4x to the negative 1 times x minus 4x to the negative 1. Don't forget that dx, still out on the outside, equals, and let's expand this out. So x times x, x squared, x times negative 4x to the power of 1 is going to give me negative 4. That's x to the positive 1, that's x to the negative 1. When we multiply them, we add the powers, which is going to give me a 0. And 4 times x to the power of 0 is 4. Similarly, when I do this, negative 4x to the negative 1 times x is going to give me negative x to the negative 1 by x to the power of 1 is the same as x to the power of 0, and x to the power of 0 is 1. 4 times 1, 4. And then a negative times a negative is a positive. 4 times 4 is 16, and x to the power of negative 1 times x to the power of negative 1 is x to the power of negative 2, because we add the powers. And that's all integrated with respect to x. So almost there now, and then getting ready to integrate. So just tidy it up. We get x squared minus 8 plus 16 x to the negative 2, and we're integrating with respect to x. Alright, so that's the groundwork done. Now we just integrate each term as we go. So the integral will equal integrating x squared. So we're going to increase that power of x by 1. We're going to multiply by 1 over that number. The integral of negative 8 is going to give me negative 8x, because if I take the derivative of negative 8x, I get 8. And similar thing here, I'm going to integrate 16x to the negative 2. Well, we need to increase that power of x by 1, which can be negative 1. I need to multiply by 1 over negative 1. And 16, positive 16, multiplied by negative 1 is negative 16. And just quickly check in your head, if I take the derivative here, the power would come down in front. So I get minus 1 times minus 16, which can be positive 16, and reduce that power by 1, I get that. So that looks good. Let's do a quick check. Make sure that we're okay. Once again, don't forget that constant c. So we'll do a check here. Integrate this, or differentiate this. 3 times 1/3 is 1. X, reduce that power by 1 squared. Integrate negative 8x, which is going to give me negative 8. And integrate this, we're going to get plus 16x to the negative 2. And then finally, integrating a constant, you get 0. So this function here is the same as this function here. Okay, that's it for the first video on integration. Get plenty of practice with this. It's going to get slightly trickier, but hopefully you found the video useful. I'll be back again with another one soon. All the best.